Okay, AP Stat, this video is going to center around Chapter 17, Binomial Distributions. Now, as we talked about in Chapter 16, we talked about discrete probability distributions. So, binomial distributions are a type of discrete probability distribution because the outcomes can be counted. In other words, we are using numbers without the decimal values between them. That would be a continuous distribution, and these are discrete distributions, just like what we talked about in Chapter 16. But in order for a distribution to be considered binomial, there are certain conditions that have to be met in order to say it's binomial and then to use the appropriate equation, formula, whatever, to find our probabilities. Okay, so when we're talking about conditions, there are 4 conditions we will address for every single one of these problems. The first thing is we are going to be only looking at 2 categories. That means the outcome could be success or failure. Success and failure are just the words we use to indicate the probability of something happening versus it not happening. The second thing is we need to have observations that are independent of one another. So for our purposes, we're going to be sampling from a large enough population that the sampling without replacement is okay. Because if your population's large enough, taking something out of it won't matter. It won't affect anything else you take out of it. All right. The third thing is that the probability of success is going to be the same for each observation. This is going to make sense when we look at a specific problem. And then the fourth one is we are going to have a fixed number of observations, and we use the letter N to designate that. So that just means that, let's say I wanted to find the probability of so many people out of 10 people that fit in a certain criteria. The N would be the 10 people because I'm only looking at those 10 individuals. Okay, so here's the deal. If the conditions for your binomial distribution are met, then you can use all of the rules associated with a binomial distribution. But you must show that the conditions are met. And you don't have to write out full sentences or anything. I'm going to show you an easy peasy, lemon squeezy way to do it. So please keep in mind, though, that if you have not shown that these conditions are met, then you can't use binomial rules. All right, so when we're talking about binomial notation, if I were to write this right here with specific values for N and P, then I would have something like this. Let's say I'm looking at 10 people and the probability of them having, or being left-handed is 0.1. Okay, so that would be my binomial distribution for N observations with a probability of 0.1. So anytime you're looking at a binomial distribution, there are 2 different types of probabilities you can find. You can find exact numbers of observations, or you can find an interval set of observations. That's where our inequalities come in. And I'm going to talk to you as we're doing examples about what all of this will look like. There are several ways you can find all of these probabilities. There's a couple of different ways you can do it in a calculator. You can use Staplet. You can do it by hand. Okay, there's lots of easy ways to do this. All right, so when we're looking at binomial probabilities where I'm looking for an exact value. In other words, I'm looking for the probability that X equals a specific value when I have a certain number of N trials. So this formula right here, it is on your formula chart. And so when you're looking at this, I know that it's a lot of letters and it looks all confusing and stuff, but this right here is actually this. And it shows us all the possible orders of our outcomes. So if you'll recall from, you probably learned this in algebra, the n factorial. For instance, if I had 4 factorial, it would mean 4 times 3 times 2 times 1. It takes that value and then multiplies every number below it all the way through to 0. It doesn't include 0, obviously. Okay, so this is just a formula on how you find all of the possible orders. I'm not going to make you do that by hand, so don't have a freak out attack. Something else that should be familiar to you is this right here. This is often used for combinations. Okay, so combinations, all the possible combinations of ways you can order these things. So this is something you could use in your calculator along with all of this. So just some information there. Because remember, when we first did probability, we had to think about all the different ways that we could have a certain probability. Guess what? If you can establish that it's binomial, there's a formula that builds that in. You don't have to think about that. Isn't that exciting, kids? I know. You're welcome. Okay, so there are also formulas for a binomial distribution for the mean and the standard deviation. And if you're a big math nerd like me, and you want to know how these formulas were derived, it is on page 392 of your textbook. I'm not going to spend time doing that because it's not really relevant to what we're doing. But if you're interested, that's where it is. Okay, so this is just some basic information about your binomial distributions. Can we use Staplet to evaluate in a binomial distribution? Absolutely. Here are the directions right here for equality, and then the binomial probabilities for inequalities can also be found in Staplet. So I've got several bits of information here for you. You can evaluate using Staplet, you can evaluate using a graphing calculator, and you can do that for the equalities and the inequalities. So I know that this is a lot of information for you, and as we go through examples, some of that is going to become a little clearer, obviously, but this is just basic information about binomial distributions. Enjoy.